Hello and welcome. We're glad you have joined us. My name is Amit New. I'm a Microsoft technical trainer specializing in security and AI. I am here to walk you through the AZ-305 course, Design Infrastructure Solutions. We invite you to step into the engine room of Azure, where every compute option from virtual machines, batch solutions, app services, containers, function apps, logic apps, and even more waits for you to shape the perfect solution. In this model, we will learn how to choose and architect the compute services to build solutions that are not only efficient and resilient, but purpose-built for modern cloud workloads. From virtual machine-based architectures to serverless and containerized. In this first session, we will cover how to choose a compute service, how to design for Azure Virtual Machine solutions, how to design for Azure Batch solutions, and design for Azure App Services solutions. So let us begin. All right, how do we choose a compute solution? Well, that depends on our needs. Compute choice is really an operating model decision. Control versus convenience, and predictability versus elasticity. Choosing the right Azure compute service for your apps is a bit like choosing the right vehicle. Let me ask you, would you try to move a house with a sports car or dash to the store in a big truck? Probably not. Same task, very different handling. That is why Azure gives us multiple compute options, because one size doesn't fit every workload. I recommend checking out the Technology Choices Guide at the Azure Architecture Center. They offer practical advice and helpful resources like the Azure Compute Decision Tree to simplify your project planning while assuring best practices implemented. The benefit of this structured approach is confidence. You're choosing compute based on clear workload signals, leading to solutions that scales better, cost less, and easier to manage. Those are the compute services we will focus on in this module. As you listen, keep asking, do I need control or do I want the platform to manage it for me? It is important to understand, is the app container-based? If yes, now you're thinking, maybe I need a managed web platform and features? That leads to app services for containers. Do I want to run a container quickly? That's ACI. And if we need full-fledged orchestration, that is a perfect fit for microservices. Choose AKS. Maybe our app is event-driven. We can choose between serverless code option with Azure Functions and workflow integration-driven designer with Logic Apps. Sometimes we need full operating system control. For example, we have a legacy IIS app that needs tight control over the operating system. That might lead us toward virtual machines. While a modern web API that just needs to scale automatically could point you to an app service. The idea is not to decide everything at once, but to quickly land on the services that make sense for your scenario. From there, the focus shifts to understanding how your application behaves in the real world. Look at the bottlenecks. Is the app CPU hungry, memory intensive, or IOS bound? Think about scaling needs, such as scaling a single microservice during business hours or across time zones, or maybe adding instances when the CPU hits 70%. For example, a nightly financial risk calculation may fit Azure Batch, while an event-driven image upload process is a great match for Azure Functions. Let's get started with the classic compute choice, designed for Azure Virtual Machine solutions. Virtual machines are the option you choose when you need maximum control and you're willing to take more responsibility from management perspective. Like when you're having a team that needs an executable to run before the application starts. In Platform as a Service, you cannot control the host like that. In virtual machines, you can. Problem solved. Virtual machines are essentially computers in the cloud where you fully control the operating system, the software, and the configuration. They're a great choice when you need maximum flexibility. For example, a finance team can move an old on-premises reporting server into an Azure Virtual Machine, keep the same setup without buying new hardware. Virtual machines are also commonly used for quick migrations and short-term needs, where speed and control matter more than automation. In Azure, you are migrating a legacy app under time pressure. You might start with virtual machine for speed, then modernize into containers or serverless-based later. You can spin them up fast, test configuration, troubleshoot issues, or extend your data center into Azure during peak demand. Think of a dev team launching a temporary VM to debug a production issue. And here is the balanced truth. It is important to know when to use VM, as well as it is important to know when not to, because with great power comes great responsibility. If you don't need operating system level control, a platform service can reduce operational risk massively. When working with virtual machines, you're not deploying just a VM. You're deploying an ecosystem, and it is important to understand our responsibilities when handling infrastructure as a service workloads. Spend some time thinking about your network configuration. It isn't trivial to change it after deployment. If you have an on-premises network, you want to carefully consider the network topology before you create any virtual machines. You must deploy an Azure VM inside a virtual network. If you have ever tried to rename an Azure resource after deployment, you know why naming is up there. It is highly recommended to decide on a pattern and enforce it with an Azure policy, so you can easily identify which VM is doing what, who is in charge, and to which environment it belongs. For example, VM SQL test 001. That will give us some consistency. We do have different offerings in different regions. Check in advance what do you have in each and every region and if it matched to your desired needs. Maybe the feature does not exist in this region. We also have some lower cost region you might consider. Azure Managed Disks are the default and the recommended option to host your operating system and persist data. Azure handles the storage account behind the scenes and let you just choose the right type, size, and encryption, making sure to take in consideration performance and caching. You can search the Azure Marketplace for compute option. There are various images that not only include the operating system, but popular software tools such as a WordPress site. Instead of setting up configuration on each component, you can install an Azure Marketplace image and get an entire stack all at once. Maintain automated update management solution for your virtual machines to ensure compliance and resolve vulnerabilities promptly. If we skip monitoring, you only learn about failures when users call you, so monitor from day one. Building one virtual machine at a time is easy, but we do need to consider all related components from networking and storage. Of course, it is a good idea to prepare for scale, but I'm getting ahead of myself. Start with the project location, the subscription, and the resource group. Then go ahead and define the virtual network. Apply segmentation through subnets. Maintain the subnets protected with Network Security Group to filter inbound and outbound traffic. Plan for outbound internet access with network address translation. have an explicit way to communicate with external services. We recommend deploying Azure Bastion for secure management. Now, it's virtual machine time. We will place it on top of the subnet through the network interface card configuration. If we have in our size a temp storage, it will live on the host as a physical SSD. For our operating system and persistent data disk, we use managed disk with minimum of 1 for the operating system. Those are handled in a backend storage account for you, so you can focus on what matters to you. From monitoring perspective, we recommend sending logs into storage account for backup and to Azure Monitor logs for ongoing analytics. Now, how do we choose the right size for our VMs? The VM family selection is where performance meets costs. Here's a simple architect model. Pick the family based on the bottleneck. If we go for general purpose, we get a balanced CPU ratio to memory for small to medium databases, low to medium traffic web servers, for example. That is a great fit. But what if we have a CPU-hungry application? For that, Compute Optimized will serve you well, like network appliances, batch processes, and app servers. Memory optimization, when we need high memory to CPU ratio, which is perfect for relational databases, caches, and in-memory analytics, we can choose that one. What about storage optimize? That will offer us high disk throughput and IAPS, ideal for big data, data warehousing, and large transactional databases. For VMs running databases like Cassandra, MongoDB, and Redis. GPU accelerated. Here's a buzzword you probably heard. That is a perfect match for heavy graphic rendering, video editing, and for machine learning model training and interfacing with deep learning. High-performance computing, the massive machine, the fastest CPU, and networking. When we require the highest performance, highest throughput for computational geoscience, financial risk analysis, for example, that will serve us quite well. Try asking the Azure Copilot, help me choose a size for my virtual machine, or which virtual machine size will best suit my requirements? Azure Copilot can help you identify the best virtual machine size based on your scenario needs from your actual available option in your subscription environment. It can even help you deploy it. Let's see it in action. In this demo, we will see how the Azure Copilot can help us choose the right size of virtual machine based on our workload requirements. Let's start with creating a new virtual machine. In the Resource Creation Wizard, we can see the starter prompt, help me choose the right VM size for my workload. We'll click on it to launch a Copilot chat. You can also use your own prompts. Azure Copilot will help us gather specific requirements that will affect the recommendation based on our actual subscription environment, including quotas and limitations. I would like to plan a deployment for my production web server. I will share the details with the Copilot. For better results, provide specific details like the type of app you would like to host. Copilot will assess what is available for us to deploy and can even help us customize configuration. Perfect. Now we have a curated list of available VM sizes to choose from to support my production web server. Let's return to the presentation. For high availability, what are our options? It is important to consider the service level agreement for the virtual machine to match to your target needs. For a single instance, you get availability of 99.9% of the time. For 2 or more instances in availability set, you get 99.95% of availability. That provides protection from internal data center failures. Highest availability within a region can be achieved with availability zones kind of deployment. That gives us 4 nines of SLA. We have a great option to automate deployment, scaling, and to achieve high availability when working with virtual machines scale sets. We recommend virtual machine scale sets when the apps support horizontal scale. If your app stores session state locally, scaling out becomes very painful. But if we have a riddle side that needs to scale automatically based on demand or schedule campaigns, for example, if we require 10 to 50 instances during the weekdays and 100 to 500 instances during campaign days, VM scale set is designed just for that. When we want elastic capacity with less operational overhead when managing individual machines. To get started securely, we have the Azure Virtual Machine baseline architecture that works as following. The user accesses the website by using the exposed public IP of the application gateway. Application gateway receives the HTTPS traffic, decrypts data, and using an external certificate for the web application firewall inspection, and re-encrypts using the internal wildcard certificate for transfer to the front end. App Gateway balances traffic across the front-end VMs and forward the request to a front-end VM. The selected front-end virtual machine communicates to the back-end virtual machine using private IP addresses of the load balancer, so we keep everything secure. It will not use the individual IP of the virtual machine. This communication is also encrypted using the internal wildcard certificate. The back-end virtual machines decrypt the request using the internal certificate. After the backend processes the request, it returns the result into the front end, which returns the result to the application gateway, and finally return the results to the end user. From the operation perspective, the operator signs in into the Azure portal or via Azure CLI. It can access the Azure Bastion service while keeping our VMs completely private and securely connect them over SSL. Next app, designed for Azure Batch solutions. This is your go-to when the workload is massive parallel job, HPC style, but managed. We recommend Azure Batch when this work splits cleanly into many small tasks: rendering, simulations, model run, big parallel transforms. You create a job that runs the process on a pool of virtual machine nodes. Behind the scenes, Batch can install the app that you want to run, schedule the task, and scale the pool. Imagine rendering 10,000 frames. Instead of one machine grinding through them, you split the work into multiple smaller tasks, run them in parallel, and gather the output at the end. That's not a clever trick. That's just Azure Batch doing its best. Azure Batch makes it easy to run large-scale parallel jobs, high-performance computing tasks with tens, hundreds, or even thousands of virtual machines all working together. Here's how it works. When you're ready to kick off a job, Azure Batch will spin up the compute VMs for you, set up the application and the data, and then run all the job's tasks, no matter how many you have. If anything goes wrong, Batch will spot the failure, requeue the task, and scale the pool down automatically as the work wraps up. It's all about getting massive compute down without the usual hassle. Let's take Milliman, for example. They accelerate actuarial modeling with Azure HPC. Milliman clients needed to run thousands of scenarios on millions of policies under tight deadlines with limited local resources. How do they do that? Milliman used the Azure HPC and Azure Batch to scale workloads worldwide, boosting speed, reliability, and cost efficiency. Insurers now finish complex actuarial tasks in hours with under 1% of a failure and up to 70% faster, allowing actuarial to focus on analysis. Dane Bolton, a senior operations specialist in Milliman, said the biggest thing with the Azure Batch is scalability. We integrated our product directly with Azure Batch, so when our clients say, I need 100,000 cores, we just give the batch workload and it handles the rest for us. Now, the platform as a service favorite for web hosting, designed for Azure App Services solutions. No servers to patch, no OS to babysit, just code. That's Azure App Services. We choose App Service when the workload is Web API, and I want PaaS. Azure manage the infrastructure, I manage the application. What do we get? Language flexibility, built-in scaling and high availability, and automated deployment from GitHub or Azure DevOps. If the application is an IaaS website and you don't need operating system level control, App Service is the quickest modernize without rewriting everything step. Questions we would like to ask ourselves. What do we pay for? We pay for the App Service plan, the bundle of infra resources that runs behind one or many applications that shares the plan. Why would I consider deployment slots? Deployment slots are a great feature. Stage a new version, validate, then swap, reducing deployment risks and downtime. If your runtime isn't supported, what do you do? Well, you can run a custom container on an App Service plan. What about security? Security. Well, identity is our new perimeter, so it is important to take in consideration the security features. Those are built in, like Microsoft Entra ID authentication and authorization. Why would you use a web jobs? What are they? Those are super great for scripts and background tasks that will run behind your app. Let's check out the web app baseline information. The inbound flow works that way. The user issues a request to the application gateway public IP address. App Gateway evaluates the policy for web application firewall to protect us against vulnerabilities from web layer, like cross-site scripting or SQL injection. If a rule detects a violation, App Gateway returns an error to the requester and stops processing. Otherwise, App Gateway routes the request to the backend pool, which in this case is the App Service default domain. The private DNS zone, private link azurewebsite.net, links the virtual network and allowing us to consume name resolution for our private networks. It contains a record that maps the app service to its default domain and private IP address. Azure DNS uses this record to resolve the default domain to the private endpoint. Application Gateway routes the request to an App Service instance through the private endpoint. So again, we have a private-to-private communication, all kept on our own virtual network. From outbound perspective, the App Service sends the request to the DNS name of the required Azure service, like Azure Key Vault, Storage, SQL Database, or any other Azure service that supports private link. The App Service Virtual Network Integration feature routes the request through the virtual network. The linked private DNS zone contains a record that maps the Azure service domain into its private IP address, so we can get the name resolution done privately from within our network. The virtual network routes the request to the service through the private endpoint. All right, time for use cases and review. We step into a real-world architecture challenge faced by a company migrating a traditional 3-tier application to Azure. The goal isn't just to lift and shift, but to modernize the design so they can scale efficiently, handle peak demands, and reduce wasted resources, all while staying in compliance with business and legal constraints. The front end, a .NET Core web application, experiences heavy spikes during peak shopping hours and struggles with performance. Yet, it sits idle most of the time. This is a classic scenario where elasticity matters. The middle tier is responsible for processing support requests. It suffers from long queues and poor customer experience, highlighting the need for asynchronous, scalable compute solution. Meanwhile, the backend SQL database performs well but must remain highly available within a single Azure region due to legal requirements. The IT team hopes we can help them modernize the application. So, how do we do that? We will analyze the requirement and follow the well-architected framework pillars to produce a high-quality, stable, and efficient cloud architecture, focusing on the front end and the middle tier. So, which compute service would you recommend? Feel free to pause the video and think it through. We have a sample solution. More than one can fit. As always, we start with the virtual network. We will configure the subnets for the front end with a network security group for protection. Same for our middle tier and for our backend. The backend stays the same with SQL servers behind the load balancer. Now, for the big question, what compute option? We can choose Virtual Machines scale set. Those are easy to scale and highly available. What about the middle tier? Well, that can also be hosted in Virtual Machines scale set, auto-scaling for changing needs. We will allow communication to the backend through the load balancer and, of course, through filtration of network security group rules. We will place another load balancer in front of the Virtual Machines scale set mid-tier to distribute requests coming from the front end. It will support automation and healing. Now, to handle incoming requests, we can use Azure App Gateway. It needs its own subnet. We will use Application Gateway with a web application firewall policy to mitigate web layer vulnerabilities, such as crawlers or cross-site scripting. We will route the traffic to the front end. Remember to configure routing rules as well as the security rules. Now, you know what to consider when building a compute solution, from the service choice to virtual machine, batch, app services. Move to part 2 to learn more about compute design options. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn. I'm Amit Nir. Thank you for watching and happy learning.